So we are back with another interview question. This is a Spring Boot interview question called Selective Retry on Network Errors. So let's read through the scenario first and then try to understand what the question is. And we'll go through the explanation of it and we'll try to figure out the answer as we go through. If you're wondering what kind of question is it, this is not a typical lead code style question. This is more of use case based question, kind of like what you will face in real world. Many companies these days ask this kind of question instead of relying on lead code kind of question. So I try to cover these kind of question on Engineering with Java newsletter. Also, I try to cover these kind of question in my YouTube channel, which is named as Engineering with Java. So this is new channel. Try to subscribe to it, and you would see more videos coming through this channel. So yeah, keep an eye on it. So let's start with this question. What does this question say? We are building a Spring Boot order service that calls an external payment gateway to authorize payments. The requirements are these: retry transient network error like timeouts and HTTP5 access response, fail fast on the 4xx errors or validation errors, apply explicit timeouts to avoid hanging threads, and do not retry on non-transient network failures like SSL handshake. Now, if you read this requirement, it seems like that the question says that we shouldn't be retrying on the errors that we know that we cannot recover from. So SSL handshake exception means we have some misconfiguration, timeouts, explicit timeouts, apply explicit timeouts to avoid hanging thread. That's understandable. And also like fail fast on 4xx error, because those are also non-recoverable. And validation errors, yes, it's not recoverable. But if you see the first point, it says retry transient network errors. So often what happens is like the servers are not available for very brief period of time, like it might be big because of network blip. So such errors generally recover in retries. So that's what it's trying to say on the first point. Now let's read through it. During a traffic spike, some payment requests failed due to network timeouts, but no retries occurred because the retry configuration was misconfigured. Now here's the main crux of the problem. It says that when there was a traffic spike, some of the payment request failed on the network error. Now as we spoke about that, when there's an error on the network error, we should be able to retry it and eventually it gets succeeded if it's a transient error. So but they're saying that even the retries were configured, it was not able to retry, and it's saying that configuration was misconfigured. So most likely our task is to find out what is wrong with this configuration. So let's expand the code. So this is the Spring service. We have a web client which is retriable max attempt 3 with the backoff delay 500, and there is a exception class that we have in the include. So what does it tell us is that we want to retry on the socket timeout exception. We should be attempting this 3 times, and we should have a backoff like 500 millisecond. Why do we need backoff? Because we just don't want to hammer the um, the system that we are connecting to. So yeah, that's the thing here with the backoff. And then yeah, we have a web client posting to authorize, and then trying to read the value by blocking the response. And if it is not able to do it in 3 tries, we have the recover method that is basically going to execute eventually. Now if you try to understand this configuration, what could go wrong? Backoff is fine, max attempt seems okay. The only thing comes to my mind is maybe the problem with the include here, the socket timeout exception. And that is also because the possibility is that the exception that is thrown after, is probably not the socket timeout exception, or there is like some other exception. So let's read through it. So first question, why didn't network timeout trigger retries? The first thing it says that when network timeout occurs in web client, we get the read timeout exception that is wrapped in the abstraction called web client request exception. So there is a wrapper class web client request exception, and then under that we have the read timeout exception. Top level exception thrown from the authorized payment method is web client request exception, and the actual root cause, which is the socket timeout exception, is wrapped inside it. So when we do the socket timeout exception dot class, with this Spring retry only checks the top level exception, not the next nested cause. Top level exception here is this web client request exception and not the socket timeout exception. So that basically tells the Spring retry to ignore the wrapped exception, and hence no retries happen for this network timeout. That's the main problem. Seems like we have it here that we configured the wrong exception class. So let's see, how would you classify the exception for? So we talked about that generally we should be retrying only the exception that are transient in nature, not the one that is going to be persistent and we will not be able to recover from, like 4xs error. So non-retriable error like SSL handshake exception, validation error, certificates error, those kind of thing we won't be able to recover from. So we shouldn't retry. But there are error codes that we should be able to retry. So we should have a retry logic for them. So we should be able to classify based on the kind of exception here. So network timeouts, read timeout exception, socket timeout, connection timeout. These are basically transient and they should be retriable because we can keep retrying them and eventually they will be a successful attempt. If it's not, we end up failing it, but yeah, there are chances that this will recover. um, so some of the example here, 500, 502, 503. Then comes the 4xx or 400 series, basically unauthorized, forbidden, not found. These are the requests that you cannot recover from. So there's no point retrying it. There is a client mistakes that's been made. So retrying is basically not going to fix the problem. So we should just fail fast and not retry on these. So there is a annotation that exclude, which is basically telling the Spring retry that which kind of exception should be excluded. And also there is a non-retriable network errors like SSL handshake exception, and then there's a peer verified. These are configuration certificate issues, shouldn't be retried, should fail fast, and we can add that into the exclude as well. So after discussing all this, what do we think that the fix for this would be? So I think whatever we have discussed so far, we should have like a custom include and exclude. Here we can basically include the web client request exception that we talked about. For the transient network issues, we can also cover the internal server error, which is like 5000, I believe, or sorry, 500. And then for the exclude part, we can add all the validation 4xxx errors, non-transient errors into it. So that would basically tell the Spring retry to not to retry on those exception. Also the important thing is that when we are configuring the retries, we should explicitly configure the timeouts. There are two type of thing we should be configuring. One is connect timeout. This is the time we need to establish the TCP connection with the server. And then there is a response time or read timeout. How much time the server we should wait for server to respond after the connection is established. So these are very important thing or important timeouts that we should configure explicitly. Without configuring these, we end up falling into the defaults, which are generally higher, and we shouldn't be using defaults because it will then block your threads for longer period. And in case of spikes, retry storms, in case of like a traffic spike, we will have the multiple connection or multiple read requests are hogging the client, and which eventually leads to the retry storm and thread exhaustion. So that's why we should configure the reasonable value. We can look into our network pattern, traffic values, and then we can configure them. Basically P99, P95 average, compare these values from the observability tool, and then try to configure the client with those values so that we have a reasonable timeout setup already. The another question is, what is a retry storm? Which techniques are useful to prevent them? So what happens is, like when we have like a transient error like network blip, we set up the retries. But what if like all of them starts retrying at the same time? So the problem is, if all of them retry same time, we are going to have so many requests hitting at the same time to the downstream servers. This basically worsen the problem because we'll have like cascading issue. So the good thing to do here is, like, we should have an exponential backoff. So the retries happens at kind of like a, there's a like not like a fixed delay, but there is like a exponential time here. So retries would be like 0.5 second, 1 second, 2 second, 4 second, and 8 second. So there's not like a fixed interval. Basically there's an increased delay, and we should also add like a jitter to randomize it, so that if two requests fail at the same time, we have like a they basically don't do retries in like a lockstep, and you have like a some distribution or variation in the retries, so that these two basically helps spread out the request pretty well. And very, these are pretty standard techniques to handle the retries and without going into the, or without having the retry storm situation. And one also the good practice is that our max attempt should be capped. You shouldn't have like infinite max attempts, because if there is genuine error, you would keep retrying, and that just basically eats up your thread and resources. So there should be always a reasonable max attempt. You can judge by that by what kind of system you're building. If it's a basically a simple client server kind of a thing, you can keep it to 3 to 5. That's a reasonable retry. If we are building, let's say, Kafka or stream processor kind of a setup, where we are writing to a destination, keeping it to the higher value is still fine, because those system can handle the lags. You are not basically exhausted with the thread issues like you have it in the in the app that is used by end users. So you can keep more max attempts there. So it depends on what kind of app you have, but there should be a cap. The other approach is to use the circuit breaker on top of it. So like, let's say you see that the downstream system has a major issue. In that case, retries, failure, and those things are good, but the better thing to implement there is circuit breaker. Basically, if circuit breaker finds that the 50% of the past request in a given duration failed, basically there is a bigger outage on the downstream side. So in that case, we should just make the circuit open, and it's going to basically fail fast, and it's not going to hit the downstream system. And then whenever we found out that the rate has increased, we make the circuit close, and then we eventually end up making request on the downstream system. So circuit breaker is a pretty good solution to solve the failure on the downstream system that is somewhat persistent for some amount of time, and not like a transient issue. um, Also, we can have timeout plus bulkhead. Basically, we can set up a bulkhead where we can limit the concurrent call that we can make to a service, preventing the overload or exhausting the service. So we can configure the concurrent calls to 50, for example, and will not have more than 50 concurrent calls hitting the downstream system. So that basically limits the number of retries we run at the same time. So yeah, that's what this question is. I hope you learn something about retry, failure mechanism, circuit breakers. Feel free to check out this question in detail. This is very a good question, and you can see many people have loved this question. So if you want to check out, go to the Engineering with Java newsletter. Here's the URL, and check out this question. And if you want more questions, go to the homepage. There's an interview question section, and it is basically a table that you can find. This is you can search the question, or you can just pagine it through. There are 3 pages. I think we have like 66 or so questions. Some of them are paid, some of them are free, so you can decide if you really want to upgrade, but if you don't, that's fine. If it's helpful, consider subscribing to the Engineering with Java newsletter. I try to cover these kind of question at least two, 1 or 2 in a week, and then there's also the weekly newsletter or digest, which I cover about different articles. This is basically summary of the articles that I read, and if they are interesting, I cover in this newsletter. I try to cover uh, 10 or so resources. So yeah, feel free to check the Engineering with Java. Also consider subscribing to the YouTube channel, so that you get more videos like this, and if it helps your interview journey, and if it's not, even if it's like in your day-to-day engineering life, I mean, consider subscribing. I'll be covering more such content in future. So yeah, that's it for this video. I'll see you in the next one. Have a good one. Bye.